Ladies and gentlemen, welcome back to another live stream. So this is the second part of these live streams in this series, but no worries, you don't have to watch the first part because I've already actually rewrote all the code that we've done in the previous part off camera, and I'm gonna show you why in a second. For now, you can join my Discord server down in the description below. Either way, let me share the stream really quickly with Discord. Okay, I'm live. All right, so we're gonna start in a few minutes. You're gonna start in a few minutes, maybe around like the 5-minute mark. So if anybody is interested to join in the stream, they can catch up. Okay. Alright, I'm gonna start at the 5-minute mark so people get a chance to join in. Let's go. Hello Theo Paris, our admin, welcome back to the live stream. Hello. We'll start at the 5-minute mark. Okay. Ryan McGowan, welcome to the live stream. My app is running Tori. I will need multi-window for sure and eventually move away from Tori. I see, that's pretty cool. So you'll definitely gonna be benefiting from the abstractions I've made off camera. We're gonna talk about that soon, once the stream starts, like the 5-minute mark. I'm gonna tell you guys about the changes I've done, like the updates. Cause like this is part 2, but you don't have to watch the first stream. And I'm gonna tell you why in a second. So yeah. Tori. So did you have any problems with Tori, or is it like maybe it doesn't support multiple windows? By the way, if you got any questions, guys, while we're not starting yet, then please let me know. Okay. I want translucent panels, and I can't do that over a wgpu viewport. That's interesting. Does Tori actually support multiple windows? Because I see like most engines doesn't support multiple windows, and even the ones that does, they usually don't support them very well. Or like, it's not this, because the thing is multi-window needs its own architecture. Like, from the start you have to keep that in mind. Because like if you just slap it on top later on, it's just gonna be just like glue, Yeah. Like multi-window really changes up the architecture a lot. And even multi-GPU, right? All Alrighty, okay, let's start. Alright. So first of all, let me tell you what's happened in the previous stream. So in the previous stream, we kind of just got a prototype, right? I started off by just writing code myself, but then I quickly started like vibe coding a lot, which kind of sucked. It went downhill really quickly because I was losing track of what really happened, you know, in the changes and so on. And also I forgot to use version control, which was a huge mistake. So what I've done off camera, I just rewrote the whole project, and I'm gonna show you what I've changed. And in fact, I wrote it by hand, like every line by hand. And it actually came up pretty well, really. It's way much nicer, way much more. Also, another problem I had with our previous project, which is that there was like a one core, kind of like godlike structure, which was having like a lot of helpers and so on. And I kind of was getting along, you know, too ahead of myself into the future before I even tried to even get a triangle going. Which sucked. So that was also a mistake. And what else? What else I had a problem with? Yeah, and I think that's it. So let me show you the new project that I've actually made. So the new project I made is basically a workspace of two crates. wgpu Kodotaku core and wgpu Kodotaku winit. So core only depends on wgpu. And obviously this error and all of them depends on that. Anyhow is only a dev dependency in both of them. Winit is a dev dependency in Kodotaku core, but it's a regular dependency in Kodotaku winit. So basically Kodotaku winit depends on core and winit, but core only depends on wgpu, and obviously Polster is also just a dev dependency. Agents will create God files unless you rein it in. You need to have one agent. No, I wasn't using an agent. I was just using, you know, like Gemini web app. But honestly, I found, from my experience, I think I should always go ahead and do that. You know, it's like basically you start off with the one project that you vibe code, where you just prototype stuff, you try things, you break things, you just go ahead and try to get it to work and see where your vision goes. So in fact, my previous live stream really have kind of shown what vision I was going for to some degree. But then right now off camera, I rewrote all of this. So that's great. Okay, so amazing. So that's the cargo.toml. Now let's go to the core and let's see what's up. So in the core, I have the dependencies is this error.workspace. So we basically, for the whole workspace, meaning all these crates that we're gonna have here, all share the same crates versions, right? So they don't fight over versions or something. And then in individual crates, which is in this folder here, you can actually create a new crate by saying new and cargo crate in if you have Rust Rover IDE. Okay, so let's see. So in cargo.toml, I said this error.workspace is equal to true, so I could use this error from the workspace dependencies. And wgpu.workspace is equal to true. Same thing with dev dependencies. I said anyhow.workspace equal to true, when it's Polster, etc. Now here's the example in the core. So nothing fancy. It doesn't do much. It just like presents a window into the screen and you're done. So it's basically the most minimal example you can make. Right, so here you got an application which contain an instance, option GPU, and a hash map of windows. So basically arc windows, winit windows essentially, and surfaces, hash map of surfaces. Obviously the key is window ID. Now here in the new function, we just initialize the instance and we just initialize the GPU, windows, and surfaces as empty. And then we have two functions or two methods. We have start and resume. Start is the function that gets called first on the resume event. And then it calls resume, in fact, itself. Though I kind of changed this just a tiny bit in the winit example, but we'll see about that soon. Anyways, so here we're creating a window. So arc new event loop create window, window attributes default, and then we're creating a temporary surface using our instance, right? and then we're using pollster to block on this async function. And here I have a GPU default with compatible surface. And here we pass it the instance and we pass it a temporary surface. Then here I said self.gpu equal to some GPU, and then self.windows insert window ID window. And finally self-resume. Notice that this start function doesn't care about like the surfaces. It only cares about the windows. And then it calls resume, which goes ahead and initialize all the surfaces. It goes through all the surfaces and extends it by self.windows iter map ID window, and it basically gives it ID and surface new GPU clone window.clone default in wrap. And yeah, so basically goes through, iterate through all the windows and create surfaces for them on the resume function. Okay, now in the run function, we just create an event loop, we run the app, and we say okay, done. And obviously this actually consumes the app, so we can't really run the app multiple times, only once. And then here should exit self.windows. So if the windows count is 1, we're just gonna close. Because I had a problem in the last live stream where I was basically destroying all windows, and for whatever reason, when you destroy all winit windows, it just like, you know, segfault when you try to exit. So instead, I just like, if we're gonna have no windows, I just exit essentially. Okay, so now in the redraw window, we just get a window ID, and then here we grab the. Now in the previous stream, I actually had a struct which contains both window and surface, you know, and then like you had one hash map here. But here I actually splitted them up into multiple hash maps because it's just like easier that way. It's more data oriented to some degree, and it also allows us to easily clear all the surfaces and stuff. But yeah, so here we say self.windows.getWindowID.inWrap, and surface self.surface is getWindowID, and texture self-res the current texture. Then we say window.prepresent notify, and then we say texture present. Okay, and then we have remove window. Now this implementation was the case before I implemented some winit stuff. Actually, no, we don't have that winit stuff here, so we'll see how that winit abstraction would look like. But yeah, so here as you can see, I'm like manually handling the windows and surfaces stuff in the core. And here when we resume, we check if we have a GPU already, meaning we have already resumed before, right? So if we do have a GPU already, we only resume the app. So meaning we just like create the surfaces again of all the windows. Otherwise, if this is the first time we run the app or we resume the app, then we're just gonna call start, which would go ahead and actually create the windows and create the GPU, then resume the surfaces. And yeah, another thing that is nice about like writing stuff on your own instead of vibe coding like before in the previous live stream is that the AI was kind of it wouldn't get as much elegant solution. It was like just spitting there a lot of weird crap. But yeah, I mean, at least it was working, so to some degree. But anyways, here we got the window event. Now we match on the event. If we got resized, then we look into the surface with that particular window ID and we resize it. Size.width, size.height. And then here we got window event, close requested. If self should exit, then we exit the event loop, meaning exit the app. Otherwise, we just remove the window. All right, and redraw requested. We just say self.redraw window. And suspended, we clear all the surfaces. So this is necessary for Android to work. And a lot of engines, even Bevy, have actually got this wrong at the first try, you know. But then they fixed it, you know, later on. But yeah, so you gotta basically clear all the surfaces. And since like the surfaces are, you know, in a separate hash map, you just say self.surfaces.clear. Okay, and finally in the main function, you just create the app, you run it, and done. That's all. Cool. Now this was the core. Let me show you now the implementation. Okay, so nothing fancy here. The GPU, let's see the GPU. So the GPU contains an instance, which is not really created in the GPU. We'll see about that. And the adapter, the device, and the queue. Cool. And it derives clone because all of these are like arcs, so they're easily clonable. So we don't really have to, like, let's say arc GPU. No need, because all of these are clonable already. All of these are handles. So yeah, and all of them are also public. So yeah. Now we got GPU info, which contains the adapter options that you want, the request adapter options. So here I'm basically giving you full control over the wgpu initialization if you want it, right? So I'm not really hard coding anything here. And here the device config, it's just like a callback, which gives you the adapter. And then you figure out a way to generate your own device descriptor. So that's cool. And here you got like a default implementation, which the adapter option is just like currently the default. Maybe later on we could provide more cooler defaults, but for now this is fine. And here we got the device config, box new. So obviously we're using box because this is like not a generic callback. This is a runtime callback, kind of. So you could easily like switch it at runtime. But yeah. The nice thing about that is that you don't have to have like a generic and GPU info and so on, which kind of suck. And it wouldn't work with the default implementation, I think. Alright, next up we got the GPU error using this error, obviously, because this is a library we shouldn't use anyhow here. Anyhow should only be used for executables like our example. And here request adapter error, it just inherits from request adapter error. Request device error, same thing. And here we got the implementation. So we just request an adapter, we grab the adapter options from the info struct, and the device descriptor we call the info the device config callback with the adapter that we got, and then we just say request device and we pass in the device descriptor that we got from the callback from the user. And yeah, so as you can see, I have nothing like all the flexibility is still there. It's just kind of like gluing all of that stuff together. So that's sick. And here we got default with compatible surface. This is just a little helper function that uses the GPU new function here. So just pass in the instance. Hello, comported box is amazing. Welcome back. Welcome. Okay, so here we're just passing in GPU info, adapter options, and I'm only like overriding the compatible surface, right? As you can see. But all the other stuff, I'm just setting them, as you can see here, to the default values. So yeah, and obviously this is an async function. And notice that I don't have those helpers that we have in the previous stream anymore, because as you've seen, like that file became humongous and it was all over the place. So no, I will go towards a design of, and we also don't have the staging belt anymore here. We're gonna see where we're gonna put that later on. But yeah, so basically I'm going for do one thing and do it well, right? So instead of like having one struct, I mean, it's kind of convenient to have one struct doing everything, but it just sucks in both development and flexibility and everything. But yeah. All right, so that's the GPU. Next up, the surface. So the surface is interesting. And here we go again. I'm becoming breathless. Anyways. So the surface stores, in fact, I kind of make it more generic. So it doesn't depend on winit. That's the first thing. And second thing, I don't assume that the user wants to use an arc surface, or arc window. So I just passed in the, the lifetime of the window here. And yeah, pub GPU, and the surface and the configuration. So here you got surface info, which only have like a configuration selector, which is basically a callback. It gives you the surface capabilities, and then you should give it the surface configuration that you want. So yeah, and you have a default values. So the default values here, as you can see, is the base format. It just goes through all the formats, and it finds if there is an sRGB format that is available. Otherwise, it just goes with the first format. And for the surface configuration, we go with the default usage of render attachment and format based format with height, present mode, auto vsync, alpha mode 0, view formats. Here we go with the base format, the add sRGB suffix. Now in OSs like I think Android and stuff, you can't really get a sRGB surface, but you can get like an sRGB view, a texture view over that normal surface. That's why we have this add sRGB suffix helper here in view formats. So add an sRGB suffix to the given texture format if the format supports it, right? And here the desired maximum frame latency too. So depending on how much, so this is kind of like a trade-off between latency and frame rate. The more frames you have of latency, the better the frame rate could be, but the worse the latency, because you're like processing multiple multiple frames beforehand in the CPU before the GPU gets to actually even, render it. So basically the GPU can get up to full speed while the CPU is like, processing 2 frames ahead, right? But yeah, anyways, next up, what we got? So we got the surface here. So the new function takes in a GPU. Hey bro, any resource you would suggest to learn Rust? It's welcome to livestream. I don't know, I would suggest just practice. It depends on what kind of background you had before, but I suggest just practice. Other than that, I would also maybe suggest the Rust book, as everybody, suggests. Although it's a bit slower pace for me personally, but if you're like completely new to Rust, then yeah, it could be useful for you. This is the first thing. The second thing, that if you're more intermediate later on, personally I found this guy very interesting in his explanations. I don't remember his name exactly, but we're gonna see. Okay, Rust. There you go, this guy. Yeah, this guy also have some very cool videos and live streams explaining some, advanced and intermediate stuff that I found very useful to me at some time in my, learning journey. But yeah, other than that, I don't really know much, to be honest with you. I just suggest also, try to support with AI and just, pick a project and try to create it. Also, obviously the Rust documentation is your best friend too, Rust documentation. The Rust documentation is like the best you can find in any other language by far. This is the first thing. And second thing, like for example, you could go to STD, let's say, and here you're gonna find all the documentation about everything that you're gonna need. So usually would have like modules, right? And like the module page would basically explain what's up, and then you could just go straight to some particular struct or whatever that you're interested in and see more about it. Other than that, what I would suggest is also the Rust language have a huge ecosystem of libraries that you could use instead of like rolling stuff on your own. So I also suggest checking out crates.io. Or like, for example, if you're interested about the ecosystem of some particular thing, you could say awesome Rust game dev, awesome Rust wgpu, you name it. So like, for example, awesome wgpu, you could see here, and you're gonna find a curated list of resources for that particular topic, so like, as you can see, learning, game dev, blah blah blah. You may find even crates, applications, examples, whatever, you name it. So yeah, these are some particular things I would suggest for anybody who want to learn Rust, pretty much. But yeah, most importantly, practice. And even with the AI, like just going ahead and learning stuff while you're creating a project is way easier than before, right? So yeah. Okay, great. What are we gonna do next? What I was doing? Let's see. What I was doing. Okay, so let's go back here. So we got the new function here. It just takes in a GPU. Notice the surface doesn't care how you create the GPU. It just takes some GPU. So this also supports multi-GPUs, not just multi-windows. So that's sick. And here you got the target. So here, instead of just taking an arc and assuming the user of this library want just an arc, I just, copy the signature of this create surface straight up. So I wouldn't sacrifice any flexibility. There you go. Target, impl, blah, blah. And this would also not depend on winit, right? Which is nice. Because if you do here winit window, then you can only use it with winit. But here the core could also be used with SDL or whatever. But yeah. So here we just create a surface. We get the capabilities. Then we pass them to the callback given by the user to select a configuration. And we pass him the surface capabilities. And there we go. Done. I also have this from raw function that I'm going to use later on in the Kodotaku winit example. Because here, if you notice in the core example, what I've did is that I just have a temporary surface and then I don't actually insert it. I just like, destroy it at the end of the start. So I create a surface and just like get rid of it immediately until we actually create the real surfaces in the resume function. But in the winit create, I've done a separate kind of strategy where I actually use that surface instead of like having a temporary one. You'll see how that works. Anyways, let's go back into GPU or surface, right? So this is the from raw. It just, instead of creating a surface as here, it just say surface get capabilities directly and stuff like that. Next up, we got the resize function. It just sets the width and the height of the configuration. And it configures the surface again with the stored GPU arc, right? So GPU device. To be honest with you, we don't even, I think, need to store maybe the GPU, or should we? No, we need it because we also need the adapter and stuff, but yeah. Next up here, we got the format. So like the render format. So here what we say is we check if the user gave us from the callback, if they gave us a view format. If so, if we have like a first format, then we're going to copy it over because otherwise we would get a reference here, as you can see. And if we couldn't find any view formats, then we just use the original surface format. So like texture views are kind of like lenses. So in Android, as I said, for example, you could have like, let's say, just a regular surface, not sRGB, but you would have, a texture view that is sRGB. But whatever, anyways. Next up, just a little helper for getting the current texture. As you can see, self-surface, get current texture. And that's what I've done for the surface, pretty much. So that's the wgpu Kodotaku core crate. Done. Next up is the winit crate. So this one, let's see the cargo toml. So this one adds in winit into the actual dependencies instead of just dev dependencies. And obviously in the dev dependencies we have anyhow and polster. And yeah, that's pretty much it. And obviously this error, although I'm currently not using it, but we may use it next. Anyways, let's see what we got. So we just have one struct currently in winit because I was still working on it, off camera. And let's see what this contains. So basically, I took the example that we had here in the core, so this, right? So this Windows and Surface, remember the hash maps here? I took them and put them in the winit crate into a Windows kind of struct, right? So the Windows struct basically is just like a container for Windows and their surfaces and stuff like that. We may even add some other stuff. So it's basically a window manager essentially. It just like have a Windows hash map and a surfaces hash map. And it have some methods obviously. So you have an add window method which just inserts into the, so it takes in a window and it just inserts it to the hash map using the ID and so on. You have an add surface function which takes in the window ID and the surface that you want to add. Now obviously here we're assuming that you have a surface static because here we're assuming that you're going to be using an arc. remove window, and remove window, remove surface, add. So add takes both window and surface and adds them both together. And yeah, now remove, it takes like removes the surface and the window, and create surfaces. For create surfaces, it's kind of more complicated. Not really complicated, but like, you know, we'll see about that. So here what I've done in the demo before, I mean, what I've done is my favorite Rust programming, which is like iterators. So we're extending. And the nice thing about using iterators is that they can be heavily optimized automatically without you doing anything much. Because like, for example, here I'm using extend. What could happen here is that Rust would look into this iterator and figure out its size, and it would automatically like reserve capacity for the extra surfaces automatically for me. And it also looks more like you know, a pipeline of declarative operations, which is quite nice in theory, but there is one problem with this which I really hate and hope at some point they're gonna fix it. And in fact, they're probably gonna fix it, which is here we can't, like, since we are inside of a callback of the map function here, we can't really propagate the error, you know, the anyhow error. So we just say inwrap here, which kind of suck. It's not the best way to do it. So what I've done instead, though there is actually some function called try_map, but this one is in the unstable Rust, I think. Yeah, probably. Let me see. So if we go here, Rust try_map or try filter, but yeah. There you go, try_map. Or is this like a crate? No. Wait, std. Or I think maybe it was like try filter or something. But whichever. Anyway, so in unstable Rust there is some new functions that starts with try, which actually solves this issue, but again, they're still in unstable Rust, so we obviously can't use them. So what I've done here, let's go back. What I've done is that I just used a regular way. So I'm going through all the windows here, right? And then I'm checking. So instead of like, you know, what is it called? Like overwriting whatever surface that is inside, as I've done in the core example. No, here I'm checking if there is a surface already or not. If there is a surface already, we just ignore it, you know, so we just go forward. If there is no surface, if the entry is vacant, then we actually go ahead and insert a new surface there. And we use the surface info callback. So the user could basically create like each surface with whatever kind of config they want. Like they could, for example, have one surface in a particular configuration and one window, another window in another configuration, depending on the window ID here. So yeah, that's basically it. And notice here, instead of saying self.surfaces, like checking if there is a surface, which would be costly, and then, you know, again trying to insert, which would like result in multiple lookups, hash lookups. No, we use this entry API, so we could do only one lookup to basically do both operations, check if the entry is vacant and also insert, as you can see here. So yeah, that's pretty much it. Next up, we all just have a little helper function for clearing all the surfaces when we get a suspend event on Android. So yeah. And we have also a get function here, which takes in an ID and returns an option, window, and surface. So if we find both a window and a surface, as you can see here, self.windows.get. So this is like Rust pattern matching. If we find both, then we return some. Otherwise, we just return none. So next up, we got get mutable. Okay, so we got option, window, mutable, surface. Now here, get mutable, the window doesn't really need to be mutable, it's just an arc, so it's unnecessary for it to be mutable at all. So we only made mutable surface here. So here we say window, self.windows.get ID, and the surface, same thing, but get mute instead, and here you go. Next up, resize. So we go through all the surfaces, We get a mutable reference, and we resize all the surfaces with the new... Wait, what the heck? Hold on. No, what the... Oh, my bad. I thought I was like iterating through all the surfaces. No. So here what we're actually doing, we're just getting one surface, but since this is an option, so it could exist or it could not exist. So what I've done is that instead of trying to error here, I just like do a fail, like a soft failure, which is if we find a surface, great, we're gonna resize it. If we don't find a surface with that particular ID, we're just gonna ignore it. So that's why I said map, because map would actually do the resize if option is sum, otherwise it wouldn't do anything. Next up, we got just an iterator here. So iter function, which returns an iterator that gives you the items window ID, window, and surface. And here we just return self.surfaces.iter.filterMap. Right, and here we use actually filter map, so because these would be an option. So if the option is sum, then we return it in the iterator, otherwise no. So here we just say self.windows.getID. So if we find the window, then we're gonna map that window into a ID, window, and surface. Where are we gonna get in the surface? Here. Actually, wait. Yeah, we're iterating through all the surfaces first, then we're getting the window. But yeah. Next up, we got the iter windows, iter surfaces. Yeah, so nothing fancy so far. So that's pretty much all the implementation. Okay, so let's go to the next thing, I guess, right now, which is the actual example demo. So the demo right now is way simpler than before. We just have an instance, an option of a GPU, and the windows. So here we say instance, blah, blah, blah. And here we create a new window. We create a surface, and we create a GPU. And then here what we do is we use the add function in the Windows abstraction. So we both add like the window and the surface. So in like before, where we just like we're creating a temporary surface, here no. We're actually just adding that surface immediately that we have created, so we don't waste that. And I'm using like from raw function to give it the raw surface here, and yeah, that's great. Next up, in the resume function, we use self.windows.create surfaces to recreate all the surfaces that we for all the windows that we have. And here I'm passing it like a callback for the surface configuration, and I'm just passing it a default surface configuration. So yeah, but you know what you could do here instead, you could even like go ahead and say, for example, surface configuration dot default, but kind of like say, wait, why this is not working? Oh no, surface config, my bad. Whoops. Is the surface config like not public or something? Wait. Surface info. Oh, surface info, my bad. So where is that? Wait a second. It was in the demo, right? Okay, here we go. So surface info. So I'm just showing you what is possible here. And what you could do is that, let's say for example, what is some option that we could change here? Actually, we only have configuration selector, so no defaults there, my bad. So what we could do instead is just like configuration selector, and then you would do box new. Okay, and then here you would get the capabilities of the surface of this particular window, and you're good to go. Now you just gotta return back a surface configuration. I think, right? There you go. And here just gonna say like, can we say default? No, we can't. But anyways, I'm just gonna show you like the kind of thing that you could do. So like for example, you could say present mode here, and you could say that if the window ID is equal to, let's say, primary window ID or something like that, then please use so basically if, I guess, if this, then use, you know, present mode auto vsync, otherwise use no vsync or something like this. So I just kind of wanted to show you what's possible here essentially. So let's just keep it as default for now, we don't care. But yeah, so that's one part. Next up we got the run function, the should exit, the redraw window. So the redraw window, I'm just using self.windows.get, and if we get some window and surface, we're gonna use them here to get a texture, pre-present notify, and then present. Nothing fancy. And in the window event, we're actually using the resize function here, and we're passing in size directly. And if self should exit, then we event loop the exit, otherwise we remove the window. And here we redraw the window. And in the suspended event, we just clear all the surfaces immediately. And that was it. That was all the code I wrote off camera. So to recreate the project we've made in the earlier stream, which was kind of vibe coded, but yeah. All right, so the real question right now is what we're gonna implement next in this stream. So, okay, so the thing is that I was looking into right now is Velo. So we should all like implement either Velo or like, what is it called? EGY, yeah. And by the way, one other note is that I've actually changed the version of wgpu we're using. As you can see, instead we were using 28, which was working fine, but I actually downgraded to 27, because if you notice here, like the ecosystem crates, like for example EGY GitHub, let's see, and if we check the, what is it? Let me first of all change the version here to the latest version instead of master, which was like 3 months ago. And in fact, even the master is still the same version, unfortunately, but yeah. And let's just check wgpu is equal to. And as you can see, it's using wgpu 27.0.1. Same thing with the with Velo renderer, which is like a 2D vector renderer of wgpu, which actually I'm probably going to use this one in this stream. Yeah, I'm probably going to use this one because that would be very interesting to test our abstractions, because it already gives us like a ready renderer for us to use, and to like, it's just a plug-in renderer, essentially plug and play. But obviously only for 2D vectors, and it's a GPU compute. You use a GPU compute, which is a very new technique, you know. So like most renderers out there, 2D renders doesn't like render vectors straight in the GPU. They just like convert the geometry into triangles first, then they render them in the, then they send them to the GPU for rendering. But here, no, this Velo renderer actually is very new, and it basically renders the actual vectors, the actual mathematical vectors in the GPU itself using compute shaders, which makes it very performant because you don't have to, you know, first of all convert the geometry into triangles, then apply them to the GPU, then render them. You just render straight into the GPU. That's the first thing. Second thing, it makes it very easy to have, let's say, some vector applications which you can easily zoom in and out, because the GPU isn't rendering like some rasterized triangles that you'd have to re-rasterize again when the zoom changes, like basically regenerate the triangles to have more precision. No, what you do is you just zoom in and it just works, because like the GPU is rendering the mathematical curves itself. So yeah, and in fact it's used in Xelim, which is their own, so they're basically dogfooding their Velo renderer here into their own like UI framework, which is also very interesting. So it's an experimental Rust architecture for reactive UI, and look at that. We may actually try to use it at some point. That would be cool. But yeah, so the reason here, they're dogfooding the 2D renderer into their UI library, which is very interesting actually. Love that. Anyways, let's go back to Velo, and I think I'm probably gonna try to integrate this in this stream. Yeah, so we could basically test out our, so we don't have to like create our own render from scratch, which would suck. Right? So it would at least allows us to kind of like evolve the other abstractions, and while like once we're done with those, we could move on to maybe trying to make our own render. But yeah, anyways, so this is like what I recommend for people that are learning wgpu, is to just adopt some plug and play render first, so you just learn the other stuff, then try to basically replace that render with your own if you need to even. Okay, so I guess let's already start maybe. Okay, so as you can see here, if we go to the latest version, where's the latest tags, I guess? Yeah, 0.7 maybe. Alright, so I think I'm just gonna create a new example possibly here, or should we, where should we put the example? Should we put it here? Yeah, sure, why not? Let's say Velo demo. Right, and what I'm gonna do, I'm gonna add Velo as a dev dependency. So we're gonna add Velo into the workspace dependencies here. There we go. And then we're gonna come to our winit crate and into cargo toml, and then we're gonna say in the dev dependencies, not dependencies, at least for now. And we're gonna say velo.workspace is equal to true. So we can use the dependency that is inside of the workspace. Next step, what we're gonna do, we're just gonna pretty much just like copy this demo right here. Okay, and we're gonna add a renderer now. Okay, so how are we gonna do that? I guess we'll find out. By the way, when was the latest version? I think it was 2 months ago. Okay, cool. Right, so we gotta figure out how we're gonna use this. Okay. And this is kind of weird because like there's multiple of these stuff. There's Velo shaders and I don't know. Anyways, let's go to src. And well, I kind of hate when examples have multiple files. Yeah, but maybe I could do something real. I mean, I could like clone this and just use zigzag, which I have here. But you know, we could maybe use something even simpler, which is get ingest or digest, or probably ingest. Yeah, there you go. So this is like a, you know, an online thing, which is very useful. So you could just paste in that thing there. Wait, I think, yeah, can I do that now? And just ingest. Okay. And yeah, as you can see, it just goes ahead and gives you all those files in one single file. You copy that, you go to Gemini, even the free model, you paste that in there, and boom. There you go. Magic. Example with the Velo. Alright. Okay. So as you can see, even the example is probably only like used in one window, but we're gonna be doing like multiple, which would be interesting. Event handling. Uses keys like a row left, a row right to switch scenes, and V to toggle vsync. Kerbo library, and find matrices. So I'm just getting like an overview over the like entire example, and then we could later on ask it for a very minimal example, because that's a huge example. Value uses affine transformations. Okay, for example, scale about a specific point, the cursor is represented by, oh, okay, so this is the formula for zooming into a particular mouse position. Instead of rendering directly to the window swap chain texture, Velo often renders to an internal target view and then performs a copy. Yeah, because I actually tried Velo a few months ago, like probably maybe 6 months or something. I don't know. I don't remember when. And I tried, at first I actually tried to like render straight into the surface, the window surface, but it didn't work. Because Velo requires the surface to be a storage texture kind of, I think, or what was it? Yeah, but the swap chain doesn't allow us to do that, at least not in wgpu, though I think in Vulkan you could probably do that. But yeah. Another nice thing that I actually noticed, by the way, is that wgpu right now, at least the latest version, actually supports mesh shaders now. And it also supports ray tracing, I think. And it even supports, was something that you could have done like already, but I just kind of refreshed my memory about, which is that you could actually like import and export Vulkan objects, let's say. So, because the thing is that I was actually didn't want to use wgpu, instead use raw Vulkan, is the fact that I wanted to use like, let's say ffmpeg Vulkan or something like that in the future, then I couldn't. But in fact I was wrong. wgpu have wgpu whole, which you could use it to basically both import and export raw handles to, let's say, Vulkan or DirectX or whichever. But yeah, anyways, so here, whichever. So we're gonna create like an off-screen texture, and then we're gonna create like a blitter using some util function, and use that to blend the texture. In fact, I think probably the example is creating their own blitter pipeline, right? I don't think they're using the utility, because most people like miss on the utility functions, which are very useful. But we'll see about that. Anyways, does the example implement its own surface texture blitter, or surface blitter, or like texture blitter? Yeah. No. It uses Velo util module. Oh, actually, wait. Apparently Velo itself have its own utility module, apparently. Okay, so that's interesting. I didn't know about that. I'm not sure why I missed that, but anyways. Okay. Anyways. Another nice thing about having Velo own its own kind of like, offline texture instead of, drawing straight to the swap chain, is that you could have any kind of size resolution for that texture, first of all. And second of all, Velo could have like full control over that texture, which is nice for renderers. And also you would need to create like an off-screen texture if you want to do some more advanced stuff like MSAA, or what is it called, HD or what? Wait, oh man, HD? No, I mean higher resolution textures, right? Yeah, like higher resolution rendering, I mean. So like instead of like drawing, yeah, HDR, yeah, that's it, HDR. Whichever performance. So HDR is essentially like, instead of rendering into like the swap chain colors like from 0 to 25 255, sorry, which is very limited precision, you render into much bigger precision, you know, and then you just kind of like tone it down using some, what is it called? I forget the names, man. Using a tone map, I think, or something like that. But yeah, use that to basically convert from HDR format, which is a higher resolution, to a format that the swap chain can actually render. But yeah, because like most monitors aren't actually HDR, but the ones that are HDR, you could use like a more higher level, like higher precision one. But yeah, anyways, by intermediate HDR, yes, you could do HDR. Ryan Mago, okay. All right, so where we were. So if you want to basically do HDR, you would use the blitter too. So you'd create like a higher resolution or higher format resolution texture, just like you would do in Velo here, and you would use the blitter to blit that into the swap chain. But yeah, anyways. Okay, so what I'm gonna ask the AI right now is, since they have like the entire official example of Velo, I'm gonna tell it to do the most simple example ever. That's the official example of the particular version of Velo I'm using. So stick to its API and make a very minimal demo example, or a minimal example for me. Okay, back. Perception models could be linear, looks flat, or perceptual like a human's vision, logarithmic, etc. Yeah, like tone maps, that does deal with that stuff, right? And even like UV formats and so on, but yeah. Okay, let's see what we got here. So Velo actually does have their own render context, as you can see here. But we're probably not going to use that. We're going to use our own GPU. So we're going to see how we could do that. And so we're going to need the renderer, or renderers. Why it made multiple renderers? That's strange. And the surface and the window and the scene. So this is why I chose Velo, because we don't have to re-implement the scene and the render ourselves. We could just use one that is already, you know, made. Okay. So, okay, can I check out the source code of that render context, so I have a little idea of what the heck's going on there? Where's the context? Wait, what? What is it called again? Velo util, okay. Render context. Now let's try to look into that thing. New, and let's see what we got. Okay, so this is the render context. It just contains like an instance and a vector of device handles, huh? So basically Velo provides you with a render context that you could already use if you don't have one already, essentially. A simple one, obviously. So you have an adapter, a device, and a queue. Okay. From build config. Ah, that's actually quite interesting. I'm probably gonna steal that. So you basically initialize the instance backends from the environment variables. As you can see, wgpu backend. And here's same thing from build config. So from build config meaning like your cargo.rs. And with env even. Also with environment. So that's sick. And here memory budget thresholds. Okay. And why it made this memory buffer thresholds though? That's weird, but okay, whichever. And here we create the instance. Yeah, we'll definitely use these maybe, but we'll see. And here you gotta create surface function, which just goes ahead and creates a render surface. And it just takes in the present mode and the width and the height in the surface. Okay, and so yeah, similar thing to what we're doing. But here it's matching on the texture format and it's checking or trying to find some RGB AU or BGR A8 norm. Otherwise it's supported because Velo only, I think, supports these formats apparently. Okay, cool. Love that. Next up, render attachment. Oh, really? Ah, I see. So this is, it's just making like the surface and then it's gonna create the off-screen targets. Sick. And here it's creating a texture blitter. Oh, actually no. They are using wgpu util texture blitter that I was talking about. So that's cool. Lovely. That's cool. Create targets. Okay, we'll use a compute shader to render. Alright. Here we sized surface, which again recreates the targets. And use clever resize semantics. What? Wait a second. Is it like tracking multiple surfaces or what the heck? Wait. Is it tracking like multiple devices? Because I'm just like curious on the context of this ones, because we could like, you know, inspire from it to improve our library. Okay. Yeah, I don't know why it's doing that. We could ask the AI actually. Here we go. Wait. There you go. So you create a compatible device handle ID. So you say new device and then you give it a compatible. Okay. I see. So this is how it's trying to handle multiple GPUs. So we could use multiple GPUs here. So you just do this. And it keeps track of all the devices here and it gives you back a handle, right? An ID. And then you could use that essentially. I see. So like you could have also ourselves like some sort of a GPU manager to handle multiple GPUs and so on, like they're doing here. But yeah, anyways, let me go back to whatever I was doing, like reading before. So I've already read this one. Okay, so you could also set the present mode. You can configure the surface. Yeah, that's pretty interesting actually. I love that. Finds or create compatible device handle ID. I mean, it's not as flexible or abstract oh my god, but it does give some great defaults, right? New device create compatible. Okay, cool. So it's looking for clear texture and pipeline cache. Interesting. Okay, cool. Next up, we got create targets. Okay, so here we create a target texture. So device create texture, texture descriptor, storage. Okay, so as you can see, you gotta make sure to add these texture flags, and obviously this format. And then we create a view, and we're good. And finally, we got here a render surface. So the render surface contains a blitter, a target view, a target texture, format, dev ID or the device ID, the config, and the surface. Okay, cool. And there's even like a helper function here that kind of like bolster essentially. Yeah, that's pretty cool actually. Love that. So basically, if you weren't using like, let's say my abstraction and you were just using Velo directly, then this would really help you get up to speed really quickly. But for us, what we're gonna do, we're gonna actually implement that stuff on our own, using our own abstraction. Okay, anyways. Okay, what's next? We also got a render and a render surface. All right, so I think let's just start trying to create this stuff. Fine. And let's see what we're gonna need. So Velo demo, right? Yeah. So how are we gonna do this? So we're gonna basically have renderers, I think. Renderers, right? Renderers. And we're gonna have like a struct called renderer. Well, obviously this is also gonna be a hash map again. And it's gonna be window ID. So every window would, wait, can't we just share the same renderer though? Wait. Is it basing this answer on actual code that you've seen, or is it just like hallucinating? Obviously the render surface is tied to a specific thing, but and in fact we're not going to be using the render context nor the render surface. We're going to be using our own abstractions for that. We're only going to be using the render of Velo. I mean, I think currently we're not like rendering multiple windows asynchronously in parallel. No, I think we're just like rendering one window after the other when it tells us to redraw that window. So I don't think this really matter. Let me just remove this in a second. I have this code. I'm gonna be using my own context and surface abstraction. I'm currently, I think, rendering windows sequentially, so I don't think that's a problem. Oh my god. We could make a GPU manager, but I feel like that's too much for now. Okay, next, multiple renders, clean, thread safe if using, blah, blah, blah. Currently, we're just assuming we're using one GPU. Oh, I love how it does this lazily here. That's interesting. Why does it do that though? Anyways, so it tries to find a render, otherwise it creates a new one with these render options. And then it prepares a scene and renders to the surface texture. And then finally Velo encodes and submit the work to the queue. No, I don't think you can render directly. You know what? I think we could just try and find out. Or let's see first what we have here. So it's only expecting the GPU here, as you can see. So the renderer itself doesn't have any clue about the surface. So I think we could probably share it just fine. Yeah. Yeah. Okay, let's just do that, bro. Let's just try that. Fine. So we have Windows and we have render. And this is going to be a Velo render. And we're also going to have like a hash map of off-screen targets. So yeah, render targets. It's going to be a hash map of window ID, comma. Now we're definitely paying for the cost of, like, you know, accessing all these hashes, but in return we get this kind of, like, you know, data oriented way of doing things, like separately. So each thing is in its own container and so on, separate, but yeah. So the window ID, and what we're gonna do here, I think we're gonna create a wgpu texture, right? Or what? Wgpu. Yeah, I mean, that's probably the case, I would guess. We'll see about that. Other than that, we're also gonna need the blitter. And for the blitter, we're gonna grab the wgpu till blitter, texture blitter. There you go. And there we go. Perfection. Alright, so how are we gonna do this? Let's see. Let's try to create the render first, I think. Maybe, if we can. But no, we need that. We can only create that after we get the GPU though. I think the same thing with the blitter and the same thing with the render targets. So no job here. Next up. But wait, since we can't do that, we gotta make sure to do this an option, to make this an option. Honestly, I think instead of having like options everywhere here, I would just like make a new struct which have all these kind of like lazily initialized stuff in there, What do you guys think? Let's see. Yeah, I think so. I mean, what I mean is, instead of having options everywhere here, we could have let's say GFX maybe. Fine. And you would have like a renderer, a blitter. I think that's all for now. I mean, we could even also put in the GPU there. Yeah, let's just put this here. And now we don't have to say option anymore here. There you go. You would just, and here would say GFX is like option of GFX. And you would also store like a GPU here too. And we wouldn't even need this anymore here. And there you go. Yeah. So now what we could do is, instead of GPU none, we could just say GFX none. And let's go. And now in the start function, we're going to create our initial resources, like our GFX essentially. So we got our window, our surface, and let's create our blitter and renderers. Sure, let's go ahead and do this. So render is equal to velo render, and let's see what it's going to need here. So it needs the device. Next step, it needs the options. Can we just say defaults, please? Yeah, it seems like it would work. I wonder what are the default values though. So the default values is that it wouldn't use the CPU. That's great. Anti-aliasing support. Yeah, okay, that's cool. This might increase what? Startup time, as more shader variations must be compiled. I see. And on macOS they have this num init threads for whatever reason. But on other like platforms they have this num init threads none. Interesting. And the pipeline cache none. Alright, so that's fine. That's fine. And here we go. We got a velo render that easily. Lovely. Next up, let's try to create a texture blitter here. Is equal to wgpu util texture blitter in new. And this one needs a device. So gpu.device and the texture format. So what texture format we're gonna be using? Well, is this like the source texture format or the destination texture format? That's the real deal. And in fact, there's even a texture blitter builder, by the way, which allows you to set up the sample type, the blend state even. And yeah, that's interesting. Though I don't think we need that much freedom for now. So the other one is fine for now. But now what I'm interested in is this format, the texture format of the texture that will be copied to, which means the destination format. So the surface texture format. Okay, so what are we gonna do for that? Well, honestly, we're just gonna use for now the main surface texture really, and call it a day. But what we should have instead, like in an ideal world, is that you would have like a hash map of texture formats map into texture blitters. So for each texture format, it would have a separate texture blitter essentially. And then you would basically lazily initialize a new texture blitter when you find a new texture format of a particular surface, right? Because in theory, every surface could have a different texture format. But for now, for a little setup and for just, For now, yeah, let's just assume that we're only gonna have only one surface format for all the surfaces that we have. So what I could do is just surface.format, right or no? What? No, not that one. Yeah, let me grab this. So this is essentially like, hold on. So this is the raw surface. So let me rename it to raw surface, and this is our actual surface. Wait, here we go. Now obviously later on, from after we finish with this, we're gonna notice some things that we could put into our library as abstractions to simplify things for other applications and so on. But yeah, anyways, so here what we're gonna do now is surface.format, and let's go. And here we're just gonna clone this, I think. Oh, I can't clone it. Fine. What we're gonna do is grab the format first. So like surface format, before we move the surface. And there we go. And here we go. We created our texture blender. What's next? Though to be honest with you, all of these should really go into this guy, GFX maybe. Yeah. So we could have like an impl GFX, pubfn, or just fnu, and it would return anyhow result GPU, or sorry, GFX, and it would basically take in a GPU or actually just clone it, right? And what else? I think that's it for now, maybe, or we'll see about that. Anyways, so let's just grab all this code right here. Nah, just this part. And let's put it here. So we're gonna need the surface format. Make your own image format next stream. We're just gonna be working on this libraries. So yeah. All right, so surface format. The render options. For the render options, we're just gonna grab those two from the user, which is us, by the way. There you go. And yeah, cool. Next step, we're just gonna say okay, self. And we're gonna say fill all of this missing fields. Oh, why it doesn't like my texture blender? Because it's not called texture blender, huh? Okay. And for the render targets, should we initialize all the render targets now? Good question. Good question. You know, let's see what the AI would say. I mean, it's just kind of like a design decision. It's not the end of the world if you go with either, but let's see. Oh, that's actually quite interesting. If window A has massive SVG and window B is just a button, Velo's internal bump allocator in the render will adjust sizes. I don't know about that. Either way, I don't care. A note on your... Anyways, whatever. So... Yeah, on demand. So lazily. Ah, yeah, I forgot about that part. Okay, cool. Get or create targets that call inside your redraw logic window. Yeah, that's sick, that's sick. So read prepare target. So we give it the window ID and the width and the height. I see. Check if we need to recreate the texture because it is missing or resized. Yeah, I see exactly what's going on here. Oh wait, while this means you technically could use a single global wgpu texture as a scratch, actually that is true. I mean, we could actually simplify it right now for that. Yeah. Yeah, actually let's keep it simple. I mean, as I said before, in an ideal world we would have a separate render target because it could be a different format, etc. In fact, but for now, let's just say render target is a wgpu texture and call it a day. Boom, done. Done. So now should we actually create the render target here or not? Can we grab the... I mean, we're gonna need the resize function anyways. Yeah. So I think, you know, let's just make it an option, fine. And let's say render target is none. Okay, next step, we're gonna say prepare target. So it's gonna take in a GPU. No, not GPU. I think we're gonna store that GPU, right? So it's gonna take width, height, and window ID. Okay. Width. So the width would be U32. I mean, in this case, since we already have access to... Actually, no. We'll just keep it that way, fine. Hi, U32. And here, what this would give... Well, we'll see about that. All right. Other than that, let's check out actually the wgpu util... Sorry, the render util stuff. Basically what I want to check right now is, and not wgpu velo util render surface, I think, right? Yeah, that's probably what I want here. Yep, there you go, target texture and target view. Can the texture splitter actually give me the texture for, like, the format if I want it? No, it doesn't give that. Cool. So we gotta store that too. Actually, let's just call it surface format, or not really surface format. Render format, to be exact. There you go. And what we're gonna do next? Target texture and target view. Okay, so where it's creating the texture again? There you go, create targets. Width, height, and device. So we're just gonna steal this code. It's pretty much ready. right? So yeah, in fact, let's just steal this whole thing maybe, and let's just put it here. And no need for the device, we could grab it from the GPU itself. So here we go, it's being used here. Okay, so just gonna say self.gpu.device. Right. I think we could just do this. Self.gpu.device.create texture. And then the size, width, and height. Format, blah blah, cool. And then we create a view and then we return it. So this is just create target. And now in prepare target, we're gonna try to do, so let me just comment out this part. And let's just say self.create target. Mutable self. Okay, and I'm gonna say create target. I'm vibe coding a Unix like system using Rust and assembly. That's cool. And here we're gonna create a target width and height. Oh, wait a second. No, I actually forgot one thing though. We can't really use the same render target because, well, each render target have its own width and height. Each window have its own window width and height. So yeah, nah, that wouldn't work. Fortunately, yeah. Okay, sure. What we're gonna do here? So the render format. Can you just remove these and just like inline them, please? Can you? Oh yeah, let's just inline those. wgpu. wgpu texture view, wgpu texture format, and what else? Okay, so let's just make this into a hash map really. I think render target option, gonna make it into a hash map, and window ID. So either window ID honestly or size, if you wanted it to make it more, you know, when it's agnostic. Yeah, actually that's true. But wait, what would happen? Like you gotta basically recreate. I mean, for now, fine. Let's just keep it this way. Fine. So this is the render targets. And it's basically a hash map. So here we got our create target helper, which takes in the width and height. And now what we gonna do? So if let, I guess some yeah, if let some or entry vacant, I guess entry, there's vacant, and what else there is? Occupied. There is also occupied. I don't even remember how she used this, by the way. Oh, I guess maybe it gives me the entry here or something. Is equal to self dot int, well, render targets dot entry window ID. And so if we got an entry, like a vacant entry, actually wait, I mean, not really. I should switch on this really. Yeah, I should switch on this. So switch, well, not switch, match on this. So we got two cases. We either already have a render target for this particular window, And at that point, what this would give us? The occupied entry, otherwise vacant entry. So I guess we could just maybe call this entry, can we? And so what we're gonna do if it's already occupied, I think we're just gonna check if it's in the right size. First of all, let's just get the texture. And we're gonna check if it's the right size. Well, let's first of all actually say let size is equal to texture dot size. Whoops, what I've done there. Okay, and wait. So now if size dot width is equal to width, and well, I guess like this, right? Size dot height is equal to height. If that's the case, we're just gonna like return the current target. Isn't it? Yeah, I think so. Where's this wgpu stuff? There we go. Remove it, please. Thank you. Okay, so what we're gonna do here? Okay, so if it's ready, we're just gonna return it. But for that, we instead of just storing one GPU texture, we're gonna store also the view here in a tuple, I think. There you go. And then we could just return, well, obviously right now we're gonna grab both the texture and the view. And then we could just return another tuple now, texture.clone and view.clone. Or we could also return just references instead, and if the user really want to own them for whatever reason, they can just clone them themselves. So yeah, let's just remove that clone, I think, and we're good. And since we're doing this perfectly with match and if and else, we could just say texture view instead of return. Otherwise, first of all, we're gonna recreate the texture. So we're gonna say let texture comma view is equal to self.create target, and we're gonna give it the width and the height, the new width and the height. Here we're basically resizing the texture by too simply recreating it. I wonder if there's like already, is there one? Wait, there's no resize, right? No, I don't think that's the case. Yeah, definitely not. Okay, cool. Okay, so what's the problem with this? Ah, I see. So we're just gonna return that stuff. Cool. So now after we create this, we're gonna actually add them into our hash map. So we're gonna say self.textures, right? Or render targets, my bad. Insert. No, entry actually. I hate that term. I use agents, and what I'm doing isn't vibe. I write specifications, agent responsibilities, and standards. It's about as vibe as being a busy software architect for 50 coders. Yeah, there's definitely a big divide there. And yeah, most people honestly kind of like mismatch them. So yeah, vibe coding is kind of like, you know, you have no clue what the heck is going on. You just let the AI generate its thing and call it a day. But there's another kind of vibe coding where you're more involved, you know. So you use kind of like the AI is just like more of a body first of all, and second of all like a coworker kind of, and second of all like what is it called? You know, syntax, like code writer, right? Essentially. But yeah. Vibe, throwing prompts like spaghetti at the wall to see what sticks. Yeah. So like for example, in the previous stream, I started off with that, you know, good side of vibe coding where I was, you know, always like involved with the code and stuff. But towards the end of the stream where I was like, you know, expanding aggressively more and more to get something working, I kind of got into the negative side of vibe coding where I was just like throwing things at the wall and hoping it sticks. That's why I actually just rewrote the whole project off camera for this stream, right? So yeah. So that's just a little experience there. Anyways, so here what we're gonna do, so we're creating a new target and we gotta basically say entry.insert the new texture and view. Is that the case? Well, we gotta clone them, that's for sure. They're just arcs. And expected, wait, what? Oh, never mind. Next up, we're just gonna return those. Essentially texture and view, I think. Isn't that the case? Well, just a reference to them though. But no, here I think you would return references to temporary references, no? Yeah, I think that's what would happen here. Unless if... Actually, insert does give us back the... the old value, okay. Can we just say entry.get here? Or no? Wait, what I'm doing here? Oh. Okay, so this is interesting. Wait a second. Can't we just return GNV here? I guess we can, maybe. Make entry mutable, okay. Uh-oh. Wait, no. Just .get, I guess? Okay, so that's sick. But if we use this instead, I think that would not work, because like it's a temporary. I mean, it's not really complaining for whichever reason, which is interesting, to be honest with you. I'm not sure why. But you know, let's just remove this for now, unless if it gives us a problem. Man, when stuff doesn't work when I vibe code, I don't get mad. I'm chill vibe code. Okay, so let TV entry.get. Okay, so I'm just gonna remove that and just do this, unless if it tells me that there is a problem here. Although I kind of see a problem here, potential problem at least, but yeah. So that's what we do here. Now, if it's vacant, well, we do kind of a similar thing to what we do here when we recreate for the size change, like for resizing, right? So I'm just gonna bring up all this stuff here, and I think we should be good to go now. Cannot borrow self as immutable because it's also borrowed as mutable. Yeah. So let's just remove this self, please, and let's just give it straight up the GPU, I think. Yeah. So this would be like a static function. And call it a day. Let's go. And now instead of saying like, where is it? Instead of saying self.createTarget, you just say self.createTarget, and then you pass in here the self.gpu, I think. Is that the case here? Would that work? Or really? What? But why? I mean, it's called create target. What the heck? Oh, it's still trying to use self though. Here. I think it's probably because I'm also using it here, maybe? Is that the case? No, I think maybe self.gpu, is that the case? This is weird. Okay, let's just comment out this part so we only deal with one part first. Because what the heck is this? Why this doesn't work? Oh. So like static functions actually gets called like this. I forgot. Yeah, my bad. So self create target. Okay. Okay, cool. Next up, we're gonna do self create target like this. But we still have a problem. Let's try to build this and let's see. So is it like the problem that I was talking about before, and why it didn't tell me that before? Kind of strange. Or is it maybe the GPU here? Because we're taking like a reference there. Wait, what? Hold on, let me make sure that we're running this demo. First of all, we gotta actually change a few things here. So like the gfx.gpu. Well, gfx.asref.gpu .inwrap, right? asref.inwrap here. .gpu then. Right. Expected. So let's do this. Now I'm just gonna copy this part, and everywhere what I'm doing like self dot, I think GPU, right? I'm gonna do I think that, right? So let's try it. No, this is some. Okay, go back. So instead of that, in this case at least, we don't really care about that part. We only care about, I think, self.gfx here. Isn't that the case? I think so. But here, for example, we do want that stuff. Wait. Kind of confused here. No. Leave it as it was. And never mind. Let's just do this stuff manually, please. Thank you. Let's do this stuff manually. Is there anything else that we need to adjust? So we only have problems here, right? But there is some other stuff loading apparently. Anyways, let's figure out what's the problem here. Okay. Or you know what? We could even ask the AI and see if he can notice. Yeah, I think that's... Wait. Oh, so we just avoided that problem altogether by just like returning clones. I see. Yeah, okay, fine. So just like use the easy way out, which is just to remove the references at all. And just straight up clone it. which is nice, cool. Might not be as like efficient as, actually we don't even need clone here because we already have done it here for the entry, so we're good. Yeah, there you go. And there we go. So what's happening here exactly is here we already got well, a window sorry, a render target for this window. Here we don't, right? And so if we don't, we're just gonna recreate it from scratch. And if we do, we're gonna check if it's the same size, you know, we're just gonna return it. If not, we're just gonna recreate it. So that's basically it. So that's sick. Love that. All right, so let's go to the next step now. I think we're good now. Lovely. Now, can I just use it or do I need something else right now? Create target, prepare target. Yeah, okay, let's see what we got. So I think it probably in the render function right now, in the redraw window. So once we got, I think, our surface texture possibly. I mean, it doesn't really matter that much, I guess, but whatever. So what we're gonna do here is we're gonna grab a target. And we're gonna basically say self.gfx.inwrap.render targets .get. Get what? Get the window ID. .inwrap. Now this is a mouthful. So instead of inwrap, we're gonna say as ref actually. And yeah, this would just give me the texture and the texture view. So honestly, instead of calling this texture, I'm gonna call this surface texture. And I'm just gonna say here texture comma view, call it a day. And there we go. And in fact, wait, no, not get render target. No. Wait, we're gonna say instead dot prepare target. And here we're gonna pass in the window ID and the width and height. The current width and height. Where are we gonna grab that? I think from the surface texture maybe? Dot width, can we? Actually, we need mutable reference here. Fine. Let's say as mute. Make self mutable. Sure. Cool. Now we got our texture and view that we need to render to. Next, we're gonna use also our blitter now. I think gfx.blitter, right? Yeah. And we're gonna copy what? So first of all, we're gonna give it the device because it doesn't store it, which is basically our gfx.gpu.device. Now, obviously, we're gonna, you know, change this into its own function in gfx, but for now, we're fine, I guess. And then we need an encoder. So we're gonna create an encoder and the source texture view. So the source texture view. So our texture view source is view, and the target is, I think we gotta maybe recreate it ourselves, right? Is that the case? Yeah, I mean, I think so. I I guess. So what we're gonna do is, do we like save create view or wait, what? The device dot create view. Bro, I forgot how do you create a view. Okay, there you go. Surface texture dot textured. Okay. Well, speaking of that, why would we not just like create the view of the texture itself too every time? I mean, I think so, maybe, but whatever. Dot texture dot create view. And here we're gonna pass in texture view descriptor. I think we could just pass in default, no? Isn't that the case? Where we're doing that? Surface view. Yeah, pretty much. Okay, cool. And here we're gonna say surface view. And actually converge. And finally we're gonna need an encoder here. And converge. Now let's create an encoder is equal to gpu.device, or what is it? Hold on. GPU self.gfx.gpu.device.create encoder. Command encoder. And what's up? Command encoder descriptor. We could just give it default, please. No? It's not, I guess. Or alright, so yeah, you just like borrow it essentially, and it would work. Next step, let's mutably borrow it, and so we're gonna make it mutable, I think. Isn't that the case? Oh, whoops, not in wrap. Let's just say as mute first, I think, or as ref. Is as ref enough? Yeah, I think it's enough. Yeah, you know what? Let's move this logic into the GFX struct, please, because this is getting out of hand already. So, okay, let's see. So you got the prepare target, the create command encoder. Yeah, this whole stuff is just the rendering, right? Right. So let's go to GFX here and let's create a new function called render. I mean, after all, I think this is called render. No, it's just GFX, fine, whichever. And here, self, and let's see what we got. So now instead of saying self.gfx, blah, 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 we're just gonna say .gpu. Actually, it's self.prepare target in this case. Right, and let's make self mutable, fine. And here we're gonna need the surface texture. So like essentially the target texture, let's call it that. Well, whatever, let's just call it surface texture for now, fine. We could like refactor it later on if we want to change the name in there to make it more generic. And we also gonna need the window ID too. But if we're getting the window ID, shouldn't we just do that other stuff too, like getting the surface, etc.? Nah, let's not do that. So the surface texture, how are we gonna grab that? So wgpu texture and the surface view, I think, right, is wtexture view. And what else? The window ID. And there you go. Now here encoder, we're gonna say just self.gpu. I'll create command encoder, and here we're gonna say self.textureBlitter.copy self.gpu.device, and here make the encoder mutable, and we're good to go. All right, and that's basically how you copy from the target to the encoder. But right now we're not rendering anything to the target, so let's do that. And by the way, let's make sure to also, submit the encoder next, I think. Is that the case? gpu.device maybe dot how do you submit it? I guess maybe, or actually Q, yeah. I think Q. And you probably do something like a std editor once maybe, and then you say encoder, I think, if I remember. Though this probably gives you some results, I think. In type mismatch. Oh no, let's actually submit, let's build the command buffer. How do you do that? I forgot. Finish function. So yeah. Do we actually need this std editor once? I think we do, but yeah, we do. Okay, so that's cool. That's lovely. Now before we copy, we gotta actually render stuff into the target. So let's say self.render to texture. And here we pass in the device, because apparently it doesn't store those for whichever reason. Fine. Self.gpu.device and self.gpu.q. Wait, why does it actually render itself? Hold on. Should that, yeah, it should be actually outside of the encoder here, because it does its own kind of encoder stuff. Right, I see. So let's remove it from here and let's put it before the current encoder, I think. No? Yes or no? Ah, man. I lost on the... Okay, so what's up? What's going on here? Q, and we gonna need the scene and the texture and params. So the scene, I think we may get it from the as a parameter, maybe. We'll see. Yeah, probably we're gonna get it as a parameter actually. So like, what is it called? Velocine. And next up, though, maybe we could just like grab a reference. Isn't that the case here? Yes, perfect. Next up, the texture and the params. So for the texture, we're gonna go with this guy, the render target essentially. And finally the render params, which is gonna, I think if we can do default now, we can't do defaults. I'm trying to remember. Import, please. Are you sure there's no defaults? Yeah, no defaults, right? Because I think we gotta pass up some stuff, apparently. Okay, so let's add the missing fields here. And let's see what we got. So first of all, the width and the height. So the width and the height, we're gonna pass them from the surface texture size. Actually, in this case, wait, why doesn't it not get it from the texture itself? That's interesting, actually. Why render take in width and height? actually already have access to texture. Okay, so apparently it's I guess for the viewport or something. Okay, whichever. All right, so let's just say texture.width, please, and here texture.height, and here the alpha color, base color. I guess let's go with white. And anti-aliasing method, AA config. So area, MSAA, or what? So I guess let's go with area for now, fine. And in use results, so let's just do something like this, I guess. And what we're gonna do for now, let's just not return anything. Let's just do this, right? And we're gonna say anyhow results, and we're good. Now what's up? Huh? No? Oh, texture view. And here what's up? Expected render params, sure. And let's go. So I think that's basically it, really. Yeah. If this is right, yeah, we still need to create a velo scene though. Yeah. But other than that, I think we're pretty much ready, which is pretty cool. Should we just create the surface view ourselves? I mean, yeah, to keep this call site, you know, for now at least, to keep it clean. I guess let's just do it, why not? And so let's just remove this from now. And there you go. Okay, so that's cool. All right, so let's see what we're gonna do next here. So we're gonna create a velo scene. Now, can we actually create it in new? I don't know, let's find out. Yeah, we could say default, apparently. So that's cool. And then we could pass in scene here, velo scene. And let's go. So what we're gonna do now, why? Apparently we're not using the surface format. I'm not sure why I put it here. Hopefully I didn't miss anything there. Anyways, other than that, what we got? So in redraw window here, we're gonna say, I guess, self.render, whoops.gfx, or isn't it? gfx.render, yeah. Render function. And here we pass in the window ID. We pass in the surface texture dot texture. Then we pass in the scene, self.scene. Now obviously self.scene should be like this. And we should also unwrap this. And for this we gotta use, do we really need an actual wage? So this only needs a reference. What else? This one also needs just references. So we don't really need a whole, so yeah. And yeah, there we go. Self.gfx, what's that? Okay, so the render needs mutable, right? Yeah. So we're gonna say as mute. And I think we're ready. I think we're done. Oh boy. Panicked. Am I missing something or what? Oh, did I remove this somehow? That's strange. Wait, what? Oh, when I was working on that GFX thing. But wait, kind of confused right now. Do we still have like that GFX thing? No. I mean, what? Oh, are we adding GFX into the thing? Oh yeah. I see. So here what we gotta do is GFX. So GFX would be GFX new, isn't that the case? And obviously we're gonna need a GPU. Oh, my bad. Hold on. Let's keep this as none here, and let's come here, right? And let's say, oh, so that's why I had the surface format, I think, maybe. So like the surface format is surface.surface, format. So that's why I was like, what? And let's do it before we consume the surface. And what we're gonna do now is create that GFX, right? So GFX is equal to what? To GFX new. And you're gonna need like a GPU clone. And the renderer options, which we're just gonna go, I guess, with defaults for now. And finally the texture format, which is the surface format, I think. And let's go. Okay, so that's, I guess, basically it. Now let's just unwrap this result and let's inject it. So self.gpu, or sorry, GFX is equal to sum GFX. And boom. And here we go. It's actually working. It's working. We got Velo working. Love that. Oh my god. So we got a full-blown render working right now. Yeah. So what we could try next is, let's say if we have multiple windows, for example. And for that, how are we gonna do it? This is spaghetti code. Let's just create a little helper really quickly here for creating a window, please. So create window, and it's gonna take the event loop. So active event loop, and it's gonna take the attributes, the window attributes, right? And it's gonna return possibly the window ID, but we'll see about that. And then it would just basically create a window. Well, anyhow results, that's for sure. But yeah, I think it should just return the window ID. And what else? Okay, so we're just gonna say okay and window.id, too simply. And now what's next? So well, actually let's store the window ID really quickly here, and let's just use that here, and let's inject it into Windows right now. Windows, what? Wait, self.windows. No. Oh, where's self? Dot add window, right? So there's add window, and add surface. We're gonna go with add function here actually, and here we're gonna pass in the window. Whoops. We're gonna pass in the window, and we're gonna create a new surface here, and we're gonna pass in the GPU. So self.gpu.gfx.wrap.gpu.clone. Next, we're gonna need a target, which is basically our window. Well, I guess we could say window.clone here. Cool. Next, what this needs, I think probably the surface config, which we could just say default, and let's go. Obviously, just say asref here, and let's go. Yeah, I think that works, but let's pass in the attributes here. And now what we could do is to simply GFX, So after creating the GFX and injecting it, we could right now just say create window, event loop, comma attributes, which is like default here, and in use result, and let's go. So now we're gonna have two windows, I think. There you go, perfect. And both are being rendered using Velo. So that's pretty sick. Love that. But why it doesn't close, by the way, properly? Is there some problem here or what? If self should exit. That's strange, but anyways. So yeah, there we go. So it's working right now. Let's just add something interesting into the scene of Velo so we can see something on the screen. So where's the Velo scene stuff? Where we're supposed to actually draw into the scene. I guess maybe every frame? Though we could probably just do it at the start of the frame maybe. Let's see. Let's figure it out. So we're gonna go to where we're creating the scene. There you go. And let's figure that out. So scene dot, and we have some draw functions. As you can see, we can draw glyphs, which is like for text using some font data. We could draw rectangles, rounded rectangles, blurred ones, drawing images even, clip layers, and stroke. Stroke is the most interesting here, I think. But is there like a begin function or something? No? There's no begin function, so I guess you just go ahead and do it. Yeah. There is a reset function though, so I'm not sure if you're supposed to call that at the start too. I don't think it would be. Yeah, I don't think. Does he write detailed specs or just vague prompts? The creator of Linux is vibing on the internet, if you didn't know. Okay. Let's just try scene.stroke. And let's see what we got here. So stroke new, and you give it some width, and you could basically use with dashes, with end cap, with join, etc. Okay, cool. Or can we just say default? Fine. And here the transform. So transforming the position of the stroke. In our case, we're just gonna say, I guess, affine default for now, and then the brush. Okay, so I'm not sure how you would use that brush part. And we're gonna need a brush transform. And finally some shape. So let's see how it's being used actually. I mean, we could use fill too, or like we could just really even steal this. In fact, I think, yeah, maybe. There you go. Okay. Cannot find red in this scope. New components. So there is no red there, but we could say either new or from RGB 8. So fine, let's go with this one. Let's say red. Does that work? And let's see. Okay, look at that. So we're now getting a smooth, very smooth circle, red circle being drawn into both of the windows using the same renderer. But obviously it like the actual canvas itself, or like the render target, it does like resize. But as you can see here, the scene, we're not like changing the scene, we're just like doing the scene once and we're done. So that's quite interesting actually. So you know what we could do? We could have like a separate scene for each window. Right? So like hash map everywhere. So this is like scenes, and you could have like scene 1 dot fill, and let's say scene 2 dot fill, and then you could just create like a scenes hash map I think from, and then you would, I don't remember how this works, because I remember you could, yeah, I think you just like passing this, like you'd say, but no, we need like windows first for the window ID. Yeah. I mean, fine. Let's create an empty hash map here. And in fact, I mean, we already have a create window here, so we could like pass in, let's say, some sort of a scene, velo scene. And in fact, maybe we could just like store a reference instead, or something like an arc or whatever. But let's just keep it simple for now, because like, for example, you could make multiple windows share the same scene, let's say. Actually, can we try to do that in fact? Sure, maybe. Like the fill, I think, is mutable, right? Yeah, so if you do that, you gotta basically use a mutex and so on. You know, let's keep things simple for now, whatever. And what I'm gonna do here is I'm gonna take this now. Whoops, I'm gonna take this whole thing. And I'm gonna come to the start function. And what we're gonna do here is, we're gonna do this, let's say here, for example, at the end of the start function. And here, this create window is supposed to give us back a window ID, okay? So this is the secondary window. And where's window.id for this one? I guess we're not storing it. Whatever, let's say self.scenes. In fact, let's store that. So let's primary window is equal to window.id. And here we're gonna say self.scenes.insert primary window, comma, scene 1. And self.scenes insert, instead of primary window, now we're gonna say secondary window, right? And scene 2. Now let's say scene 2, let's change the color, for example. Let's make it blue, whichever. Oh, and here we're gonna, select the scene depending on the window ID. So get window ID in wrap, obviously, and let's go. And now, there you go. Oh, let's go. So that's pretty much work. And in fact, right now we're ready to make like a whole paint app easily, a vector painting app, multiple windows. So that's pretty cool. Oh my. All right. So I think I'll probably create like a separate crate. So now that we're actually done with this, so let's just first of all see what changes we've done here. Wait, cargo toml. So we just added velo into the workspace, but obviously just the dev dependencies for now. We added velo and finally the velo demo. So let's add this velo commit and boom. All right. Now actually we should wait, render. Okay, whichever. Okay, so let's think about what abstractions right now we could grab from this. I mean, I think I'm probably gonna make like another crate just for velo support, built-in velo support. Like you would have wgpu kodotaku velo, and it would just depend on core and winit, and it would have this logic already built in. Yeah, I think so. Apparently we're not using the render format, huh? Why? Well, I mean, I guess if we don't need it, we don't need it. It's fine. Actually, we do. Wait, not. Keep it here at least. Other than that, we're good. Let's just amend this. Let me make sure that it's still working just fine, just in case. You never know. Fine. And let's just amend this commit really quickly, and let's go. Okay, so let's think about this. So, I mean, we could even have like this struct, which would contain the render. I mean, to be honest with you, just this part of having like a texture blitter and render targets, this part alone is like not just necessary only for what is it called, for velo. It's also necessary for any other kinds of similar use cases, right, other than velo. And then later on we could make like another crate for velo specifically, which add the extra logic to bundle a renderer, a GPU, and whatever abstraction we're gonna make out of this. But yeah. Okay, so is there any questions so far? Yeah, I think I'll probably bundle this texture blitter with the render targets. And I'll probably make maybe this texture blitter a hash map too. Another thing that I'm thinking about though is having like some sort of a blitter cache in some sense, right? Where Like you could basically lazily initialize new texture blenders, as I said, depending on the format, basically. But yeah, so how much time we've been? Yeah, I think maybe at this point I'll probably just end the stream to keep it like self-contained, because we've done enough today. Like we've implemented like a whole render pretty much. Do you plan on using for GUI? We could try to implement EGY too, or we could try to roll our own using Velo. Unless if maybe there were some like already built in Velo EGY backend. I mean, that's possible. I mean, I don't see any of that. So I guess there is none. So you would probably want to make it on your own, I guess. Or we could just like, integrate EGY directly. Yeah. Is there any other questions? Yeah, because I mean, I could go even further, like more, but I just want to keep this stream like self-contained, because we've done some interesting stuff today, like we integrated Velo. But yeah. So what we could do is we could have yet another crate that would give you support for EGY2. So that would be cool, really. Yeah, let me see. So this is Velo. Okay, where are the crates? So there's encoding shaders. Yeah, I don't see EGY here. Well, how about issues? Is there any discussions about it by any chance? No, I don't think. Yeah, no. So we'll see about that. What do you guys think? Like, what should we use for you? Should we just... I mean, we could try to make our own even. We could try even make it our own. I don't know. That could be its own stream, to be honest with you. That could be its own stream. So yeah, I guess that was it for this, guys, for this stream. Thank you all for watching, and see you the next one. Goodbye, everyone.